Probability of compound events. Let's try to understand few terms which we'll always come across when dealing with compound events. Now, whenever you get across sentences like pick two items randomly, draw three cards, probability of event A and B, probability of event A or B, these sentences lead to compound events. As you can see, here we don't have one single event. There are combination of events, right? So such combinations, whenever you get across, or whenever there is more than one event involved, we treat them as compound events. Now, this is a vast subject. To simplify it, we have categorized it into few groups. So one is independent events and dependent events, and the other one is mutually exclusive events and not mutually exclusive events. Now in this video, I'll try to explain you how to figure out whether the event is independent or dependent, or whether the event is mutually exclusive or not mutually exclusive. Now that is kind of most important exercise to solve any problem dealing with probability on compound events. Now there are a few keywords which you should keep in mind so that you can get your answer very fast. For example, let's consider independent events. Now the event will be independent if it is not affecting the following events, right? Or it is not getting affected by the previous event. So those events will be independent events. So few events are most of the time, or you should say always, independent. For example, tossing a coin, right? So let me write few examples which are always independent, and that is first is toss coin. So whenever we have toss a coin, it is fairly independent because coins will have head or tail. So whether you toss them one time, two times, three times, any times you want, there are only two choices, right? And the second toss is independent of the previous one, correct? So tossing a coin will be independent event. And the second kind of things which gives you like roll a die, right? Roll a die, right? Roll die will be an independent event because die has got six faces. Whenever you roll it, it has its six faces. So that is not going to change. So it's like whether you roll it for the first time, second time, third time, or nth time, the probability of getting 6 will be 1 out of 6, correct? So it doesn't really get affected. Now that is, broadly speaking, independent events. Now there are few keywords which help us decide whether the event is independent or not. So that keyword is replaced or not replaced. So when we say pick two items randomly or draw three cards. Now when we say draw three cards, then important condition here in the word problem will be, which you have to read very carefully and understand, is whether the cards were replaced or not, right? So if the cards were replaced, right, so the key word here is replaced, then it is independent event. So if you find a keyword replaced, right, so that means you draw one card and then you put it back and then draw the second card. So in that case, in drawing the second card, you are working with the same set of numbers, you said it, or same set of group. And therefore, the probability for the second event is not influenced by the outcome of the first one. Do you get the point? Right? Let us say you have a deck of 52 cards, right? So you have 52 cards here and you draw one card out. So 51 remains. Now if you draw the second time a card without replacing, then the total number of outcomes have been reduced from 52 to 52 minus 1, that is 51. And of course, probability of the event is going to change since the total number of outcomes have changed. Do you see that? So that means now if you're not replacing, it is dependent on what you got in the first place. So no replacement, right? No replacement means dependent event, right? Or if I do it simultaneously, So if I do simultaneously, that means there is no scope of replacement, right? I just draw two cards. Then I will have to consider that I picked one first and second next time. So first card will give me probability of favorable over 52, and second will be probability of favorable over 51, right? So that is how we will say, well, it is no more an independent event since the first event really affects the second one. The set has changed. So that is how you can figure out whether an event is independent or dependent. You have to ask a very simple question. That is, the first event, does it affect the output of the second event? If it does, that means we are dealing with dependent events. If not, then we are dealing with independent events, right? So that is how we consider these two cases. Now, one more thing, and that is about and or in a probability problem. When we say probability of event A and probability of event B, right? So when we say and, that means the probability or the chances of getting two things in a sequence must be much lesser, right? And probabilities are numbers less than 1. They are between 0 to 1. So how do you get a lesser number when you're dealing with less than 1? That is when you multiply, correct? So whenever we are dealing with AND operation, let me write here AND operation, then, and if we are considering two events A and B, then the probability will be probability of A times probability of B. So whenever we have a condition which involves AND, we know its probability should be multiplied of the two events. And normally in AND problems, we are also considering independent and dependent events. So AND is normally associated with independent events or dependent events. So whenever there is an AND operation, the second thing which we have to figure out is whether the event is independent or dependent. So that goes hand in hand. If in a probability question we have OR, like find the probability of event A or event B. In that case, we know the probability should be probability of A plus probability of B, right? Because we got more options, right? So we are expecting bigger numbers. Well, of course less than 1, but bigger than probability of either one of those, right? So we say, when you draw a card, what is the probability of getting an ace or a king, right? So the probability gets added up. So that is how you can see how to classify your compound events. So now OR, whenever OR is there, second most important thing to think about is whether these two events are mutually exclusive or not. So like OR, when we ever consider OR, means that we think like this or that, right? This or that. But normally in OR, funny part is that there is a lot of AND involved. There's a lot of AND involved. Do you see that part? So when we talk about OR, we also talk about AND. So in our question is, let us say this is event A, and we say, well, the probability of this is A, and we'll consider probability of the other part as probability of B, right? So we have this. Now if you are interested in OR, we will add probability of A and B. But when you do so, you add this twice, right? You add this portion twice. Once with A, once with B. Therefore, in such cases, that what you are adding twice, it is common between the two, should be taken away. So in this case, we have to take away probability of A and B, right? So whenever we are dealing with OR, then we have to see what is common between the two. And whatever is common, it has been added twice when you do addition of probabilities of A and B. So that value should be taken away. That is what it is. And how do you know that whether we have something in common or not? That is mutually exclusive or not mutually exclusive. If the events are mutually exclusive, that means there is nothing common, right? Nothing common. So this value in that case will be 0. If the events are mutually exclusive, that means if the events are kind of like this, in that case, this set is 0. So that is mutually exclusive event, right? So this is what we are talking about when mutually exclusive event is there. And this, when the events are mutually exclusive, then there's nothing common between them. For example, we can say, well, when you roll a die, then probability of getting 6 or 4. Now there is nothing common between these two. Either you get 6 or you get 4. So those probabilities just get added up, right? How about this? Probability of getting 6, or that means probability of getting even number. Now there is overlap. 6 is also an even number. Do you see that? So there is an overlap. So in such cases, we have to exclude what is common. And these are examples of not mutually exclusive events. For example, in game of cards, when you are drawing 3 cards or 2 cards, whatever, so you say probability of ace plus probability of hearts. In this, you know, there is one ace of hearts also. So you should take away from this probability of ace of hearts, right? Because that has been added twice. Do you get the point? So probability of getting ace plus probability of getting hearts minus probability of getting ace of hearts will give you the right answer for the event of drawing ace or a card of hearts. I hope you get the point. Since this event, these two events are not mutually exclusive. They have something in common. But on the other hand, if we say probability of rolling a die and getting a number 4 or a number 6, now there's nothing common in between, right? So these are mutually exclusive events where there's nothing in common. In general, you should remember, whenever we have OR, then the formula is probability of A plus probability of B minus probability of A and B happening together. Now if the event is mutually exclusive, then this probability is 0. If the event is not mutually exclusive, then this is not 0, right? So easy way to remember is that if a probability question has OR in it, we are looking for mutually exclusive or mutually not exclusive, but the formula is probability of A plus probability of B minus probability of A and B, right? I hope you understand with this the terms which we are using. Let me now summarize it. Probability of compound events means we are dealing with more than one event at the same time. Now, if in the question we have probability of event A and probability of event B, that means their probabilities should get multiplied. So, and will involve probability of A times probability of B. But if in the question we have OR, that means probability of A or probability of B, in that case the probability of these two will really get added up, right? So and basically means this. And means, let me just sketch in a diagram similar to this. And means we are only interested in the common part. Do you see that? So we are only interested in this common part. That is and for us. So when we are interested in only that part, then it is probability of A times probability of B. In case of OR, we are interested in both the parts, but not in the middle part. We are interested in the middle part only once, not twice. Correct? So it could be these two conditions. This is mutually exclusive, where they have nothing in common. And this is not mutually exclusive, they have something in common. Now that something gets added up twice when you add these two probabilities, and therefore we need to take it out. That is it. So in general, you think like this. Whenever there is an OR condition, you have to add the probabilities and take away whatever is common. If there is nothing common, then it is mutually exclusive case, right? If there is something common, it is not mutually exclusive case, right? So you take out something. If it is mutually exclusive, you don't take out anything, you just add them up. So this is a short way of understanding these terms. And with that, let's move on to questions dealing with compound events. I hope that helps you. Thank you and all the best.